to determine even or odd algebraically, the rule it's very simple, but I want to show you why this rule works. To do this, find for any okay. To do this, plug in negative x into the function. Okay. Why are we doing that? Why are we doing that? I wanted to show you in this graph. This is an even function, right? When I plugged in -2 into this even function, I got +4. To be symmetric, to have that line of to have that symmetry about the y-axis, I should plug in +2, the positive version of this -2, and I should get the same y value, okay? Because it's 2 to the right and 2 to the left, both have to be on the same point to be symmetric, right? So when you plug in a +2 and when you plug in a -2, their y value should come out to be the same. When you plug in a +1 and when you plug in a -1, their y value should be the same to be symmetric, right? So for example, if I plug in, I'm going to just go ahead and type in the number here. Say that I plug in 5 in here. If I plug in 5, it comes out to be 25. If I plug in -25, it's going to go, -5, it's going to come out to be +25 again. So in even function, this is always going to happen. The positive number and the negative number, whatever you plug in, you will get the same y value, okay? So when you plug in -x, that's going to give you the same answer as what you will get when you plug in +x. So when you plug in negative x into the function, and things will simplify, signs will simplify, and it gives you the exact same expression, then what you can tell is that the function is even, okay? I'll do that example here, okay? To check it algebraically, I'm going to find f of -x, which means everywhere you see x, plug in -x. So that will be -2 times -x to the 4th power plus 5 times -x squared, okay? And now what we're going to do is we're going to simplify these power terms, okay? So -2 times, what's that orange circle part going to give you? Well, -x to the 4th power is -x times -x times -x times -x, right? But if you multiply negative 4 times, these two will pair up and give us positive. These two will pair up and give us positive. So the whole thing turns out to be positive, right? Positive x to the 4th power. So don't have to write it down every time. I want you to know that whenever the exponent is even, it's going to come out to be positive. So I'm going to say this is x to the 4th power positive, and I'll bring down the other one. And again, this is an even exponent. So when you do -x squared, that's going to come out to be +x squared. Now, if you compare this, okay, to the original f of x, okay, the original f of x was -2x to the 4th plus 5x squared. You notice how it's exactly the same, right? This is exactly the same as the original f of x, okay? If that happens, okay, since f of x is exactly the same as f of -x, we know that f is an even function. If it comes out to be exactly the same as the original f of x, that's when you can say it is an even function. I'll show you a shortcut though. If you're looking at a polynomial function, take a look at their exponents. If all their exponents are even, it's going to be an even function, okay? Because the exponent was 4 and 2, both of them are even. If you have any odd exponent mixed in, then you're going to have to say it's neither even or odd. But this, you know, I sometimes use that shortcut, but this is the longer work, okay? This is what you're going to have to do. Plug in -x to see if it comes out to be the exact same f of x, And if that's okay, you get to say that it is an even function. Let me try another one down here on f, okay? Let me do this one with you. The rule is the same. Just to see what it is, we will plug in negative x into the function. So everywhere I see x, I'm going to plug in negative x. All right, so that will be negative 2 times negative x to the fourth minus 4 times negative x to the third plus negative x minus 5. Okay, and now what you have to do is you have to simplify these powers. Okay, got 2. So what's that going to be? I will have negative 2 times, look at this, we're raising negative x to the fourth power. 4 is an even number, which means this negative sign will turn into positive. This purple circle term will turn into just positive x to the fourth. Next, I copy down the minus 4. But when I do this negative x to the third power, well, do you agree that is gonna stay as negative, right? That's gonna stay as negative because this number is odd. All right, going on, I have a plus sign and a minus sign. That will give me minus x and negative 5. Let me simplify this one more. Minus 2x to the fourth. But now I'm looking at a subtracting a negative. If I multiply negative times negative, that will be a positive 4x to the third. And I'm going to bring down the rest of them exactly the same. Let's compare this to the original function. This is h of negative x. Comparing to the original function up, let's see, start with the first term. Negative 2x to the fourth stay the same. Okay, that's the same, right? What about the next term? Next term was minus 4x to the third, right? That was negative 4x to the third. But that turned into positive. See, it's not even function anymore. It's not an even function because this term changed the sign. Not only that, the next term also changed the sign. So if it's not the same, it's not even, okay? If every term turned into its opposite sign, we say that's odd, but you know, we have a mixed terms, right? Some of them stay the same, some of them change into the opposite term. So this case, it's just going to be neither. It's neither even or odd. And we could simply find that out by looking at their exponents, don't you think? So take a look. The original function right here has an exponent of 4, which is even. So this could have been an even function. Oh, but look at that. That's an odd exponent. And what's another one? This one right there, when we don't have an exponent written down, we know there is x to the first power. These two are odd. These two are odd. But this one was even. So if you have a mixed case like that, that's when the signs, some of them will change, some of them will remain the same, and that's why this function is neither even or odd. So that rule, I think, that's a shortcut, isn't it? Just simply by looking at the exponent. So if I apply that method over here, let's just check the exponents then. Okay, what are the exponents? I have 3 exponents, right? The first one is 5. That's odd. So this function has a chance of being an odd function. Next one, oh look, that's a 3. That's another odd number. So far so good. I think it's going to be an odd function. What about the last one? That's 7x to the first power. And 1 is an odd number. Because all exponents are odd, we can say this is an odd function. If one of them is even, we're going to have to say neither, okay? You can also plug in negative x into this function, and you will see that g of negative x will be the opposite of g of x, okay? So every sign in the original function will be switched. I won't do that, because this method worked out great for us. But this is the condition to be the odd function, okay? When you plug in negative x, the entire function will have an opposite sign, like every single term. So if that happens, we get to say it's an odd function. Now, I can't really apply that exponent rule for this one because this middle term is an absolute value. So you know what I may do is I will try to do this graphically. Okay, I know they said algebraically, but I do want to see this graphically to see what it looks like, okay? So the function is absolute value, oh, well, we had an x squared term first, right? So I'll go ahead and type y equals x squared. And then we have plus absolute value of x. And what was the number? -2? I think it was. So look at this graph. This graph is perfectly symmetric about the y-axis. So I know the answer is even. This is an even function. But how do we do this algebraically? So let me go back. I think I typed a different number, -2 instead of -3. But I don't think that's going to make a difference much. It just shifted it down one more unit. But it's still an even function because it is symmetric about the y-axis. But let's do this algebraically. I will find what p of -x is. What will happen if I plug in -x? Well, the first will be -x squared. The next will be absolute value of -x minus 3. So let's simplify each term. Well, that is just going to turn into positive, right? -x times -x is positive x squared. And if you think about this part, absolute value of a negative number will just come out to be that number, because absolute value, they take care of these negative symbols. It's about distance from 0. So I can just rewrite that as absolute value of x, because absolute value of -x is the same as absolute value of positive x. -3 just comes down, and as you can see, this is same as p of x. So when you have p of x equals p of -x, what you get from plugging in -x comes out to be exactly the same as the original function. This tells us this is an even function. And we also confirmed it graphically, right? When you graphed it, it was perfectly symmetric about the y-axis. So I kind of used a mixed method here, but you know, we got two proof that it is even, right? All right, how about this one? I do want to see what it looks like on the picture. So let me go ahead and graph this first. So square root of y equals square root of 3x squared. I forgot what was inside. Plus 1. Looking at this looks like a smooth weak function. This is an even function, right? It is symmetric about the y-axis. To the right side of y-axis is exactly the same as the left side of y-axis. So I think we already got the answer. This is even function. Even by looking at the graph. But how about we confirm this algebraically? Plug in -x into the function. You will have 3 times -x squared plus 1. I see what's going to happen now. The -x squared will turn into positive x squared, because negative times negative is positive. And what we get is this is exactly the same as the original r of x. So we can say that since r of x and r of -x are the same, r is an even function. So when you plug in -x and it comes out to be the same as the original, that is how you can tell that it is an even function. All right, last one. I have 1 over 2x to the third. What does it look like? I do y equals a fraction. How do I make it a fraction? Okay, I'll just do 1 divided by 2 times x to the third power. All right, by the look of it, this looks like an odd function, right? I have this piece in the first quadrant. If I go to the diagonal quadrant to the third, it's flipped upside down. This looks like an odd function. So let's confirm it. Let's confirm this. I may be able to check out the tables too. You notice something right here? Like when you plug in -2, the decimal comes out to be -0.0625. But when you plug in +2, it's the same value, but the number is opposite, right? So by looking at the table, I think we found an odd function. But let's do this algebraically, okay? So if I plug in -x, what will happen? I will get 1 over 2 times -x to the third power. Now focusing on this, 1 over 2, we'll just have to wait. If you multiply negative x 3 times, it will just be negative x to the third power, okay? It looks like the 3 just came inside, but that's what it is. And if I multiply this 2 and this negative x to the third power, I can just write them next to each other, right? I can just write them next to each other. But what I'm going to do is I'm going to pull out that minus sign in front of the fraction, okay? Look, the original function was a positive version of that. When I plugged in negative x, it came out to be exactly the same, but just opposite in sign. So that tells us since q of negative x came out to be the opposite of q of x, just in sign, we know q is an odd function. For many of these polynomial functions, that exponent rule, like this, will work just fine. But there are some other tricky ones that I want you to practice on your homework this week. And sometimes the only option is us either graphing it or, plugging in negative x to see if it comes out to be the same or the opposite. So if I summarize what we just talked about, if f of x equals f of negative x, if what you get and simplify after plugging in negative x is the same, we're looking at even function. Okay? But when you plug in negative, may I change the order here? I'll change the order. If you plug in negative x and it comes out to be the same as the original f of x, then it's an even function. But if you plug in negative x, it's not the same, but it's just all opposite in sign, it is an odd function. If neither of these cases are true, then you're going to have to say neither or neither, otherwise. So try these problems in your homework for me. Now you learn how to tell whether a function is even or odd graphically, and you also know how to do them algebraically.